Okay, let's take a look at question number 9. Question number 9 says a game consists of rolling a die. So what are the outcomes here? I'm going to create a probability distribution here. The outcomes are 1 to 6. 1, 2, 3, 4, 5, 6. And if the number you receive, so it says a game consists of rolling a die. If an even number shows up, you receive double the value. So I'm going to have another row here where I have to have what our points are, because our points are really what our outcome is. We roll the die and we get 6 possible ways, but the points is our outcome. So it says if an even number shows, you receive double the value on the upper face. So here's an even number, so we get a 4. This is an even number, so we would get double that value, which is 8. And this is an even number, so we get double that value, which is 12. If an odd number shows, you lose points equivalent to triple the value of the upper face. So this is equivalent to -3. This is equivalent to -9, and this is equivalent to -15. So those are the different outcomes of this game. Now, what's the probability? Well, the probability of each of these things occurring is exactly the same. It's 1 in 6. So these are all have the same probability. So that is the probability of X occurring. Now it says, what is the expectation? So the expectation is we take what our outcome actually is and multiply it by the probability of that outcome. So the expected value here is -3 times 1/6 plus 4 times 1/6 plus -9 times 1/6 plus 8 times 1/6 plus -15 times 1/6, and lastly plus 12 times 1/6. And like I did before, I can factor out the 1/6 here and make this just a little bit easier to plug into a calculator if I want to. So it's -3 plus 4 minus 9 plus 8 minus 15 plus 12. So now I just have to add up what's in there. So -3 plus 4 is 1. Minus 9 is -8. Plus 8 is 0. Minus 15 takes us to -15. And plus 12 is -3. So this tells us that our outcome is -3/6, or -1/2. This means that this is not a fair game because the expected outcome is a backwards movement. Now, when it says a fair game, you're asking who's it fair for. So is it fair for the player? Is it fair for the house? Let's say we're talking about a gambling game or something like that. It depends on who's playing, like which point of view you are, whether it's a fair game, which which favors you. In this case, this favors, if this were a casino game, it would favor the house because you're actually more expected to lose. If it favors anyone in particular, then it's not a fair game. So in order for it to be a fair game, your expected value has to be 0. 0 means that it doesn't favor you winning and it doesn't favor them winning. If you're playing a game and the expected value is positive for you, that means that it favors you. Okay. If it's negative, that means it favors the other person. So what you're looking for a fair game is that it favors nobody, so your expected value is 0.